Well, my screen was sharing a second ago. Here we go. All right, we are going to get started.
This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Leigh Bortins, and it's Monday, February 6th, 2023. Welcome to the Math Map Book Club, where Kirsty, Gilpin, and I discuss a math concept each week from our soon-to-be-released math curriculum for families with students in classical conversations communities. Kirsty and I spent a lot of years talking about the difficulties of math education, and we found there are many reasons, but they can be identified and then they can be overcome, and we hope this gives you hope. So I realized today that I wanted to share with you that I'm obsessed with patterns. It all began when I was about 8 years old. I can remember it kicking in, and I can't not count things. So I guess I'm OCD in some sort of way. But I count traffic lights and I count shutters on houses that I go by, and I can't not count them. Kirsty, do you have any weird math quirks?
Well, I was just thinking when you said that I have a tendency, like if I see numbers, I'm always making up equations, right? Or trying to figure out like, oh, you know, that's a Bible verse or this. I'm always recognizing something unique about numbers or license plates.
Yeah, I think some people just see numbers and patterns in visual things as the way other people hear notes and music and hum. So this book club's a little different because we're studying one lesson a week from a math text over 30 weeks in 2023. Just so you know, we're going to repeat it next year. We'll have fresh material then, though. And we're going to take the summer off. The book club schedule is designed for parents who want to prepare to teach their children ahead of time. So we are discussing the first semester through this spring and the second semester next fall. To access the Math Map, you need to be a member of Classical Conversation CC Connected Community. Please feel free to participate in the discussion, even if you're not in CC, as we will share screens on the things we're discussing as we talk about math. Each week, we'll consider a quotation that's part of our exordium for the Math Map lessons, or I should say, a reflection of some kind. So we're going to be talking about multiplication tonight. And Kirsty, do you want to share with us the part of the reflection that you're interested in?
Sure. I highlighted the verse this week, Genesis 1:22, and God blessed them, saying, "Be fruitful and multiply, and fill the waters in the seas, and let fowl multiply in the earth." And it hit me when I was choosing it. I always love when there's an echo, Old and New Testament echoes of one another. And I thought the echo to me of this was when he says, you know, to go out and make disciples, right? That we are called to be fruitful. He calls it that there's the fruit of the Spirit. So we should be fruitful in that way, that people should see us and see the Spirit, the evidence of the Spirit in us through the fruit of the Spirit. But then we're also supposed to go out and be fruitful in sharing the gospel with the lost world and with people who desperately need to hear the good news. So I just always appreciate the fact that God does that He gives us these ideas that echo back and forth between the Old and New Testament. And that was just what I saw this week.
Great. Does anybody else want to chime in on this verse? Sometimes when we read these Bible verses these days, I'm wondering, like it says, fowl, let fowl multiply in the earth. I suspect you guys are all old enough to know what a fowl is, but that's kind of an archaic word. I wonder if young people would even know what it means. So one of the things we can also help them do is multiply their vocabulary by reading things that are a little bit difficult, as well as doing some math that's a little bit difficult.
I think of multiplying money. So he talked about burying, that parable of the people who were paid and one buried it to save it instead of maybe investing it or growing it in some way.
A lot of multiplication going on. Anybody else? Okay, well, I'm going to give you something to think about, but I'm going to kick off some more information. We're going to talk about flashcards tonight. So while we kind of continue introducing the math map, just start thinking about flashcard stories to share with us later in the evening. So Kirsty and I have stumbled upon two things that we feel like the math map's going to resolve. One, that math is a foreign language, even though it's a universal language. And we are hoping people will learn how to read the notation and speak the language before they worry too much about calculations. And then the other one is that we all say math is orderly, but we're not too good at explaining the actual order. And so the math map is a way to help us have, a peg, a place where we can hang our math ideas. And the more you use the math map, the more you'll see what we're talking about. So we're going to begin our book discussion. We have discovered in having these over the last month that if we jump into the topic sooner, the rest of the club starts to feel more comfortable talking. So we do want you to feel free to turn on your camera, chat questions and comments at the bottom of the screen. Julie Melendez, our producer, will help facilitate our conversation. And so while you think about stories about flashcards, let's let Kirsty introduce the math map, lesson 5 on multiplication. Kirsty, what do you have for us tonight?
So, well, I was just going back one slide. I was just going to highlight, and we can talk about it here. But just as we talk about that order, last week I looked at the dimensions, and so this week I thought I would hone in and specifically look at what we include in 0D and 1D. So we've talked about 0D being numbers, and then when we talk about 1D, we refer to that as our linear space, where we really focus on arithmetic. And so we spent a week talking about comparison, how all the numbers line up. And last week we talked about hopping back and forth from counting and then adding, right, multiple hops at a time. And now multiplication is going to move us away from the origin even faster when we're using whole numbers. And so this whole idea of linear space is looking at the number line and how the operations help us to kind of move up and down the number line. So it gives us a place that we can actually look at these operations and see how they work that's a little bit more concrete than just thinking about numbers, right? We can actually see how things are working on the number line. And as we get familiar with how they work, sort of at the piece of the number line we're familiar with, those big numbers, we're going to be able to follow those same patterns. We're going to make those abstractions. And so I just wanted to point that out, that for the next couple of weeks, we're going to be finishing that up. It's all arithmetic. And I want to point out that every year, students are going to be working on comparison, addition, multiplication, and so forth of their domain. So this year, we're just talking about natural numbers and how we can operate on those. And if we were actually going through the math map and next year picking our next domain, we would take that idea and we would expand it to talk about positive and negative numbers, the integers. And so I just wanted to point that out so that we're going to kind of build this idea of the math map over the course of the next few weeks so that hopefully people are becoming more familiar with it.
So something you've brought up before, to sort of reiterate, is that, Christ is our origin and the math map has an origin. And in addition to that, it's just like nobody can speak without giving him praise. The simplest sentence there is I am. That's his name, Yahweh. So we couldn't have language and sentence structure if he hadn't given us his name. But he's also given us math ideas. He's one God in 3 persons, the second of which is Jesus Christ. And those are all natural numbers. And so it's just really interesting to me how some of the best revelation about who the Trinity is in arithmetic and in natural numbers. You don't have to go into really, high-level mathematics to meet him. So before we continue, I want to thank our sponsor, CC Connected, where the math booklets discussed by the club can be downloaded by Classical Conversations members. Look ahead to the book club schedule on leighbortins.com under the Math Map Book Club tile. And for next week, work through the lesson 6 division, and we'll be discussing that. And go to CC Connected to download the naturals, which is in beta form. And Kirsty just referred to that we're looking at natural numbers a lot this year. And please show up, even if you haven't reviewed the booklet for the week. So before we actually jump into the book club time itself, I want to go back to the flashcards. I've been trying to post once a week some sort of question or topic for the club to consider, to give you a heads up before you get here. And so I wanted to share with you one way that I use flashcards with our 4 sons. And I actually ran a math club long before I ran started classical conversations. And one of the games that all kids of all ages really liked was just to get a plain old deck of cards. But you can remove the face cards, or if they're older, assign a point value to them. And I would let the children would stand in a row, and I'd let somebody pick a number. Depending on their age, it might be something low like 2, 3, 4, or 7, or 22 if they're older. And then what they would do is I would throw a card on the floor, and the first person in line answered that the number they gave me times what was on the floor. And then they'd run around to the back of the line and fly. Well, I was throwing another card down, and another brother was answering that. And so it gave them a way to run around. Well, I just flashed cards onto the floor, and they were doing multiplication. I think boys like doing math that way. Anybody else have some ideas?
All right, let me look at the chat here. When my kids were little, we would hide the cards around the house, then give them a sum or factor, and they would run and try and find the right card. That sounds like fun, Jennifer.
That is really good. I wish I thought that one.
Uh-huh.
Well, I have those grandbabies. How about you, Julie? Do you have some grandbabies?
Oh, yes.
It's never too late to
It's
practice.
never. I am actually going to screenshot this right here so I don't forget it. No, I have the recording, so it's there now. Thank you, Jennifer, for my grandchildren. Well, thank
So
you.
one of the reasons we wanted to bring up flashcards is because Classical Conversations actually already sells addition and multiplication flashcards, but something that's not apparent in the beta on CC Connected is that there's an entire flashcard system that goes with the math map. For those of you that have looked at the beta, at the top right corner of page 1, 5, 9, and 13, which would correlate to the first page of 4 pages a day, there's in the corner this word flashcards. And it's to remind you or your student to go grab the flashcards and to do those before you do anything else. And one thing that's going to be really difficult for us with type A personalities or high expectations for our children in math is to believe that the flashcards are more important than the curriculum. Getting those facts super solid will make it so that the reading of the notation, the calculation, the problem solving will be a lot easier. So that's why we have it as the first thing of each day of the math map curriculum. So if anyone wants to chat stories in as we go on, that would be great. And we'll stop and talk about them. But Kirsty, why don't you start taking us through your big ideas for this week?
Sure. So I was just going to say, and I'm going to be honest with you, that I was fondly remembering when we would play basketball with flashcards. And so if the kids got the flashcard right, they could shoot a basket. So similar idea, right? Getting the kids moving while we were out there. And you may have said this, and I was lost in my memories. But just that when we think math facts, we think addition and subtraction, but that right, math grammar is the language. It's more than just, there's a lot of math grammar beyond the facts. And so all the flashcards that we have in development are going to be really exciting for helping, I think, families to see how much of the grammar is going to be helpful when they get that. So
let's just talk about that a minute, because it's about flashcards. So it's just a highlight of the heads up with highlights coming. When it comes to like integrals and derivatives, when it comes to matrices, a lot of the higher math, we have flashcards for those. So your little, 3, 4, 5-year-olds can start learning the vocabulary of math when they're that young. I remember when we first introduced the timeline cards a long time ago, when we used Veritas Press before we made our own CC cards. There was a card about Amenhotep IV and monotheism. And I always got a kick out of how many parents told me their 3, 4, 5-year-old named the new dog or the new cat Amenhotep, right? So we know that they can do it and they can listen. And this will be the purpose of the flashcards, is just to build good math vocabulary before they're asked to do anything with it.
So Julie, if you want to go ahead a couple of slides to, so now what we talked about tonight was, and I thought I would address this because, you know, we talk about Common Core and all these things that people are like, they're doing weird things with multiplication. And I just wanted to point out to you tonight that we just talked about how important it is to know your math facts, right? And we can, flashcards are a great way to do that. You know, we start with skip counting. So we really want to emphasize students having those math facts. Once we get beyond single digit multiplication, all multiplication comes from the distributive law. And so we have a lot of different ways it's arranged. And I just thought that I would look at right, two that we're familiar with, right? That I can write, let me turn on, thought I turned it on, but and let me move the people. There we go. So we have, we can do 30 times 4 horizontally. And when we're looking at sort of small numbers, a lot of us go, oh, well, that's not hard to think of. And we can write the answer and we come up with 120, right? As the problems perhaps get a little bit more complex, we may sometimes think that we'd like to see things vertically, right? Because it helps us to arrange what we're doing and see the process. And then we have, and that's still 120, right? And then this is where you might have those weird Common Core things, right? Where they're using boxes and kids are writing things like 3, 0, and 0, 4, and then they're going through. And what I want to help us see tonight is that these are all just different ways of using the distributive law. So let's look on the left-hand side of your screen and just review that for people who don't remember that, right? If you maybe, I'm trying to think, yeah, you may not have gotten there in your foundations memory work quite yet, but it basically says that if I have a number and I multiply it by the sum, right, some sum, that it's the same thing as that number times each addend and then added together. And when we do it with letters, it feels like kind of overwhelming. And we may be tempted to think, oh, that's just for algebra, because we may remember the days where we had things like 3 times x plus 1, and we had to distribute this, right? And we would sometimes use the little arrows to come up with 3x plus 3 times 1, which is 3. But I want to take these two ideas and I want to show you how they're connected. Because really, when I have 30 times 4, what I'm really saying is that I have 3 tens, right? That's my 30. I should have picked another number, and 0 ones, right? And so now I'm multiplying both of these parts by 4. So I'm going to erase this and do it with better numbers to help you see. There's probably a faster way to erase, but it's kind of fun.
I'm just impressed you can draw and talk at the same time.
All right, so let's use something similar. Let's use 32 times 4. And again, most of us probably can think of that in our head and say, well, that would be 128. Okay. If not, maybe you say, well, I'm going to rewrite that vertically. And let me point out to you what you're doing, right? When we do this vertically, I say 4 times 2 is 8, right? And then 4 times 3 is 12. And so I write that down. But really what I'm saying is 4 times 2 ones is 8 ones, and 4 times 3 tens is 12 tens. And so notice that that's why I have my hundreds, my tens, and my ones. But that's where I can write this as, if I have 30 plus 2 times 4, I can now see, what am I doing? I'm multiplying my 30 tens by 4 and my 2 ones by 4. And so I get my 120 plus my 8 and my 128. And so it doesn't really matter how I arrange this. All of these different arrangements are really just ways of helping me to keep track of what I'm distributing. Because it can get, right, if I was to write this out as the distributive property, I just want you to, it's going to look ugly, but I just want you to see that all we're doing is repeatedly applying the distributive property. That if I had 34, oops, try and stay with the same number, 32 times 24, right? If I was to do this vertically, I would have my 4 times 2, there's my 8, my 4 times 30, there's my 120, right? That's how that builds. But now I'm multiplying by 20, which is why that 0 goes there. Because whatever I'm multiplying by here, I'm really multiplying by 2 tens, right? And so it's 20 times 2, which is 40. That's where that 0 comes from. And there's my 4. And then 20 times 30, that's my 600. And now I can add those together and come up with that. But if I was to write this same problem using the distributive property, right, I would have my 30 plus 2 times 24, right? And so I might start with that, and I'm going to distribute my 24. And so now I have 30 times 24 plus 2 times 24. But now I'm going to expand my 24, and so I end up with 30 times 20 plus 4 plus 2 times 20 plus 4. Right. And if you can see all the things that I'm doing, that's what I did over here in this arrangement, right? It's just hidden. And so now I have 30 times 20, that's my 600, plus 30 times 4, there's my 120, plus 2 times 20, there's my 40, plus 2 times 4, there's my 8. And now when I add them all together, I end up with 768. And I think that one of the things that we are going to accomplish by spending time on arithmetic every year and multiplication every year is helping students to become familiar and appreciative of the power of the distributive property. Because I think a lot of us think, oh, that's just for algebra, but it's not, right? It's how we do all of our multiplication. And so when people start getting worried about whether it's written vertically or whether it's written in a box or done diagonally, or the way the Japanese do it with their lines crisscrossing, right? All it is different ways of arranging the distributive property to make sure that I multiply everything the way that I'm supposed to. And so if you are a master of the distributive property, you can multiply anything in any different arrangement. So that's my encouragement for you tonight.
Donna has a good question. She has, would it be simplifying or complicating it to do 30 plus 4 in parentheses, then parentheses 20 plus 4 parentheses?
So Donna, it's going to be the same. A lot of times when we see two binomials, right, we're I didn't write them both out, but that's basically what I did, right? If I had written this out, let me change my color here. There's a way I can do this. Right, if I had written 30 plus 2 times 20 plus 4, I would have distributed one of my binomials to show all my work, right? And so a lot of you might be going, oh, binomials, FOIL, and all of these other things. Those are all shortcuts, right? If I was showing all of my work to a student to say, hey, this is why this works, I would have taken one of my binomials, so perhaps the 30 plus 2, and I would have distributed the 30 plus 2 over my terms and had 30 plus 2 times 20 plus 30 plus 2 times 4, and then I would have gone ahead and now distributed back this way. So it really doesn't matter. It's just making sure that each time you do it, you're distributing so that everything eventually gets crossed correctly.
So the thing for me that's important here is this over practice of arithmetic and its various forms. And here you just distributing. This is what makes it so that some students can just see the patterns in algebra and others can't. Right, we've done so many of these simple problems that then when you start substituting it with letters or you know, pi, e, theta, phi, sine of theta, whatever it is, we kind of can intuit what's going on. And you can we could have a totally different discussion about how using a calculator to do these kind of multiplications makes it almost impossible to train your brain to do algebra. Somebody want to comment on that?
Well, Leigh, I would just say it's not just the calculator, right? It's an over reliance on tricks or algorithms without understanding the underlying, right?
Yeah.
That this requires us to understand place value. And if we can understand a number, it can be that 24 is 20 plus 4, and I can write it that way. Well, then it's not as big a step to go to x plus 4, right? And so understanding the why things happen. That was one of my experiences as a teacher, was that kids just memorized an algorithm, and then if something didn't look like the algorithm, they were stunk.
But there's a lot of chat, so Julie, why don't you go through some of them?
Yeah, so Leanne, I don't know, Leanne, do you want to unmute and ask your question? Because I am not familiar with this word you typed. Abacus.
Oh, hi guys. Sorry. I think my audio is going to work. So today I just happened upon a discussion in a book that I think Dr. Gilpin has as required reading in the course she's teaching right now. It's Mathematics for Human Flourishing, and it's an excellent book. But he mentioned today the abacus. And so I was not familiar with an abacus. Do you guys know what an abacus is? It's like the thing with the beads on it. And I didn't know really how it worked. And so I watched a couple of videos on how the abacus works to teach mathematics. And to me, it seemed an excellent way to help students visualize this distribution. Oh, I hope you guys aren't losing me. In multiplication. And so I just wondered if you could comment on, is there still a place for use of the abacus in mathematics studies?
I have a question, Leanne. The one that you were watching, was it showing you how to use an abacus where 5 was the number they mostly used, or 10?
It was 10.
Kirsty, you want to explain how to use one?
Well, I was just thinking, I have an abacus. I don't think I have my abacus here. I think it's at the Math Map offices.
I can go get it. No, I'm kidding. Tell me what it is.
So I actually did with my kids, we did use an abacus when they were younger. And I did find it to be a helpful tool for little fingers to be able to move things around and to see patterns. It is one more, right? It's not something that we do in our country on a regular basis. So it is one more place where parents kind of would need to invest the time to train themselves. But I certainly think that, it can be a great tool if you've got some guidance and to help your kids work with it. the one that we used it was for math education, and it was great, and it was good for trades, right? So helping them to see like 10 ones, and they would like literally move 10 1 beads and move up a 10 bead. So they would see those equivalences and how that built over the course of time. So yeah, there's a lot of things you can do with an abacus. We haven't really included it, just again because it's not something that a lot of people have a comfort level with, but we used it in our homeschool.
So Kirsty and I are old. I'm going to include you with me. Yeah, so that was interesting about bringing up the abacus. There was also something we used called a slide rule. And what's interesting is as calculators have taken over more and more, the just basic tools that just families had that they used to teach basic operations are disappearing. So I'm real proud of you, Leanne, and the rest of you. If you find of anything else you want to share with us, you all should look into using an abacus. It is a great tool. You should look at slide rules. You should look at folding tape measures. There's just, a variety of things that have disappeared that we used to use regularly.
I think, didn't Saxon Math have the abacus in the like very pack you could buy for the very first level? I think it was in there. I think we actually had one too.
So
That's fun.
Here's proof of what a geek I was in high school, because I actually have a slide rule. I thought it was in here by my desk, but I have a slide rule, and in high school I insisted on using the slide rule instead of a calculator. So I was a geek. What can I say?
Well, I got another story related to that. When the third year after we started the challenge program, so it was 2001 in that time frame, one of our students had gone on to college, and she calls me up really just hot under the collar and says, "Mrs. Bortins, my calculus professor would not accept my calculus work today because he asked me where my tape was." And I looked at him and I said, "What's a tape?" And he said, "The thing that you use to do all the calculus calculations on." And she said, "I used my brain and a piece of paper," and he would not believe her. That was 22 years ago. So I was real proud of her.
Wow. Donna had a question. She asked, what is your opinion on teaching students multiple forms rather than having one way that you work to perfect? So do you need more information? Does Donna need to elaborate on that? Does that make sense?
So teaching, what I was talking about is teaching, like, when you're teaching multiplication, we'll teach it, horizontally and vertically, because that's the way we learned it, or at least I did back in the 70s and 80s. And, we tend to stick to that one, but our children don't necessarily, they may work better with the cross, so teaching them multiple forms and allowing them to pick, or is it better just to teach them one or two and stick with those?
I am all for them finding the method that works best for them if they understand the distributive law, right? And that to me is the biggest or the saddest thing about so many of the arguments I've heard about sort of Common Core are those parents who go, they're teaching what's wrong with the way I did it, right? Why do we have a new multiplication? And we don't, right? There is no new multiplication. So helping them to see, right? If we, right? If our kids are really good at this, right? But they don't understand that it's 30 plus 2 and 20 plus 4, and that we're distributing that. If they don't understand that and they just go, well, you always put a 0 here. Well, why? I don't know, because you always put a 0 there, right? Then we haven't done them any favors. And we can teach them 5 different ways of arranging it, And if they don't know what they're arranging, right? I mean, I can write this, right? I mean, and this, I think, when you get to, I think this is a really helpful way, but again, boxes and Japanese diagonals, whatever it is that works, right? Because I could write this 30 plus 2 times 20 plus 4, right? And be explicit with my tens and ones, right? One of the things that we keep talking about in the math map are how much is hidden, right? All the hidden zeros and ones we talk about, right? But place value hides a lot of things too, right? And so when we write our numbers out, and I just realized that purple is nearly impossible to see, right? 30 plus 2 and 20 plus 4, right? I can multiply, and now I can really clearly see I'm distributing my 4 and then I'm distributing my 20 as I work that out, right? And so helping students to recognize the hidden place value and the hidden distributive law, I think, is going to enable them to use any of those forms or methods. In the math map, we really focus on either recognizing the horizontal and the vertical being the same. But I don't have a problem with parents saying, hey, look, you can arrange it any way you want to keep track of your work.
It reminds me kind of the question people would ask us about which pronunciation in Latin to use, and insisting that it had to be one way. And I just kept thinking, tomato, tomato, y'all, yins. Any way that you can express things using synonyms or even antonyms or close to synonyms just helps you to think about things. And so I always wonder, are these kind of American questions? Because if you grow up in a country where all the children know 2, 3, or 4 languages, aren't they always thinking in different ways for, while they're processing information? So I think it's also a benefit. I agree with everything Kirsty said. The one thing though to note is there is still a reason for the rote memorization. It's not just speed and accuracy, which would help also in a problem like this, but there's no system that's going to show you 7 times 8 is 56. There's some basic things you just have to memorize. So while you're at it, why not just memorize the pattern a little bit farther along, because that'll help you in other arenas. I'm also wondering, Kirsty, could you take that 30 plus 2 and your 20 plus 4 and maybe change it to A and B, C and D, and show us how it distributes when there's letters?
Sure. But I was just when you said that, one of the things in Francis Sue's book is he talks about the freedoms of math, and the first freedom he talks about is is it the freedom? But this freedom that we have of choosing the right tool. And so if my child has memorized 15 times 15, right, here's an opportunity. They know this because they've multiplied this for years in CC, and they know it. But now I can use this and say, okay, well, show me how the distributive law works in different forms. Did you get the same answer? And so now they can use their memory work, and then you can build on that to help them understand the distributive property. And then if I know I'm doing this and multiplying it, and they say, okay, well, I really believe this pattern now. I take 5 times 5 and I have 25, and 5 times 10 and I have 50, and 10 times 5 and I have 50, and 10 times 10 and I have 100, and I add them all together and I get 225. And now I can say, okay, well, what if I had A plus 5 and B plus 5, right? And I can slowly build and say, okay, well, go ahead, right? Well, I still do 5 times 5 is 25. 5 times A is 5 times A. B times 5 is the same as 5 times B, and B times A is A times B. Well, I'll go ahead and add all of those together, and I have AB plus 5A plus 5B plus 25, right? And so I can, and that's the idea of our domains, is being able to gradually work. So I started off with Memoria, And then I've demonstrated a law, the distributive law, right? And now I've used this concrete example to make an abstraction to show that this is going to work for any number, because now I could say, let's get rid of those 5s. And if those 5s were different letters, C and D, for example, right? Now I can get rid of this. And I can show through this abstraction, well, this is going to work for anything. D times C, D times C, D times A, D times A, B times C, and B times A. And notice here that this is not a hard concept. It's challenging notation, right? Because I just write my letters next to each other. And so all of a sudden they're going, well, what does DC and DA mean? Well, it just means D times C and D times A. And so when we're hammering home the importance of notation and being able to read the math, that's what we're talking about. And now I add these together. None of them are alike. And so I can just literally write out DC plus DA plus BC plus BA. And that's my answer. And so I've taken my student from memory work that maybe they just memorized it, right? Like Amenhotep, right? We don't necessarily know anything about him, but we know it's true. We've broken it apart now and looked at its place value. We've looked at the distributive law, and then, right? I mean, you can almost with a child use memory, right? Point, 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 point. We'll do the same thing with just letters instead of numbers.
Good. Thank you. I hope everybody's seeing the value of arithmetic to prepare your students for algebra, and that if you have older children who are struggling with algebra, just stop for a while and go back and do arithmetic. Just give their brain a rest while they're building new patterns and, you know, more solid information. Okay, what else we got in our chat there?
Well, Beth is just saying she loves that CC redeems the parents' education while giving the children the quality, and that this is how she intuitively did math, but now to have like a visual to it is really helpful, and it helps. She says she's being challenged to think of things differently than she did in the past, so that's great.
Like Donna's comments about the slide ruler and the moon. It is so true. So, you know, you guys heard that famous phrase, Houston, we have a problem. That was from the Apollo 13. The guy in Houston who took that call actually is my neighbor. He's very old.
Oh,
It's just fun fact.
that's so funny.
One thing I was going to say, I appreciate this writing it out instead of a calculator, because just you get to play with it, and you get to, like, you would fool around with it. Like, you can fool around with numbers and letters, but also if you quote, try something that doesn't work, like if you multiplied B times D or A times, if you got something out of whack, you know what I mean? It's so helpful, because then you can kind of pause and go, wow, well, that also reinforces the distributive property. You know, that's what's so fun about this, is that you get your hands in the dirt, so to speak, instead of just punching in numbers on a calculator. You can't see this whole, this array of opportunities. And that's what's to me fascinating about math, because you can play with it, and you can either reinforce a property, or you can reinforce it negatively by saying, oh, this is why, how it doesn't, or I mean, this doesn't work this way. And that just reinforces why it has to work this way. So I find that really fascinating. So yeah, I love paper and pencil. So it's good.
So I guess before you leave, I want to just share a takeaway. We got a few seconds left, but I want to challenge you guys to take that visual that Kirsty gave us with the A plus C and the B plus D, or however she framed those letters, and be analogous with the other things you do with your children and grandchildren. So for instance, I might play tic-tac-toe or dot to dot to keep them quiet, or we might go to the board and sketch butterflies. And why is it I never go to the board and mess around with A plus B plus C plus D and have them substitute simple things in? Right? We just don't even think to play with the visuals. And I know they'd be so much more responsive if you're standing in front of a board or using a stick in the sand and there's not an actual math book anywhere nearby. So let's keep thinking about how we can encourage each other to just bring math in our daily lives.
That's good. I have one more question if you want to just quick answer. Beth is asking, and I think it's appropriate to ask here, kind of the future of the beta timeline and the eventual release. So I don't know that we've ever said that out loud.
Can we say that for next time?
That would be good.
And we'll definitely do. We'll give it some justice rather than rush it.
Yeah.
I'll get in trouble. Someone will yell at me if I don't say something right.
Well, now people will definitely have to come back next week.
Yes, come back next week. It is recorded, so no. Bye, everyone. Have a good night.